Alright, so we've looked at the idea about extrusive and intrusive rocks. Well, let's just do a little another video here, an information and a practical on small or large crystals. So we can see here we've got some beautiful purple amethyst here to look at our crystal structure. And this is just a nice visual because it's forming very large crystals here. And so we have slow cooling. But we can also have fast cooling with extrusive rocks. So in this video, we're going to look at how that happens and then do a little practical with it, which happens a lot in school labs. And of course you can do it at home as well. Alright, so here we have our volcano. And when we talk about intrusive rocks, remember from before we said that they are slow cooling and we get large crystals, and so we can see that here with our granite. What that means is when it's cooling slowly, the atoms have time to arrange themselves into repeated units. So this repeated unit is known as a crystal lattice, right? A lattice. So let's write that down. So we have a lattice, and that's when we have a repeated unit. Think of it like lattice that you might buy at a gardening store. It's a repeated unit. Well, this is a crystal lattice, and that happens because the atoms have time to arrange themselves in that pattern. Okay. Whereas if we have a look at extrusive rocks, those that are formed on the outside, they are fast cooling, which means they don't have time for the atoms to arrange themselves in these nice little patterns, and it's more random, right? And as you can see, this random approach to adding them gives us very small crystals, okay, for extrusive rocks. We call this random approach amorphous, right? Morph meaning shape, and amorphous just means it doesn't have much of a shape, a repeated unit. So what we're going to do to model this in the lab and see the effect of cooling slow and fast on crystal size, we're going to use some copper sulfate. So what we're going to do here, you can see I've got a picture here of one of our results, but let me explain before I press play on the video. What we're going to do is we're going to get some copper sulfate and a little bit of chemistry revision. So that is our solute. We're going to put that into some water, which is called that should be the solvent, and then we make a solution. So these two should be switched around. So we should have the solvent, which is water, and then we have the solution, which is the problem, which is the solute plus the solvent. So make sure you swap those around, okay? All right, so once we make our copper sulfate solution, we just don't want to just stop there and add a little bit. We want to add a lot. So we want to make something called a supersaturated solution. What does that mean? Well, it means that we're adding so much copper sulfate in there until no more dissolves. And so we can see here we've got an unsaturated solution. We just added a little bit of copper sulfate. Now we want to add more to make a saturated, but we want to keep adding it. So we want to heat it. We want to heat the copper sulfate up so we make a supersaturated solution. And what that means is that when it cools down, that water can no longer hold the copper sulfate, and it comes out and forms crystals. And so that's what we're going to be doing. And so you can see here in the video the results of that. When we cool it down really fast, we get very tiny crystals. So we get some copper sulfate, put it in a petri dish or a test tube, and we cool it fast with some cold water. But then what we can do is we can also cool it down slowly. And when we cool it down slowly and just let it slowly cool down and in the room, over a day or two, we start forming very, very big crystals. And so we're sort of simulating the difference between cooling fast, that is extrusive rock, versus cooling slow, intrusive rock, large crystals. Okay, now where can you do this at home, and where have you seen it? Well, here is some rock candy that has that same sort of idea. We can eat this one, right? And at home you can do the same sort of experiment. What you can do is you can get some sugar. You make a supersaturated solution of sugar. We can just make super saturation of sugar, and then you get some string. You put the string in like so. So let's say you get a cup. You put your supersaturated solution of sugar till no more dissolves. So you need some help with, if you're young, with parents. If not, just make sure you ask permission. You heat the water up, get some hot water, put as much sugar as you can in there, and then what you do is you get a beaker or a cup, you put a pencil across the top, and you put a string in there, and you leave it on the side bench to cool down somewhere. And what happens is the sugar that's in the solution starts forming crystals on the outside of the string, and then we end up with a similar situation right here. Okay, And so that is how you can make your own large crystals at home. So hopefully now we've looked at our practical application of course, our intrusive versus extrusive rock by making different crystals based upon the temperature at which they cool. So that's it. Make sure you've got your notes down, you understand the key concept behind it, and it can explain why do they make large crystals when it cools slowly. Why? Because the atoms have time to rearrange themselves into this repeating unit known as a crystal lattice. So I'll see you in the next video. Until then, keep exploring and keep revising.